Hello, my name is Shahabdin Mohageg. I'm the director of West Virginia University Laboratory for Engineering Application of Data Science, also known as WV Leads. This lecture is about a general overview of artificial intelligence and machine learning for this course that you're taking. I will start by talking about learning how to code uh, using Python as a language, and then the paradigm shift that has been taking place in science and technology. Then I will provide some definitions of AI and machine learning. I will also talk about how physics is modeled using data. Then I will talk about the engineering application of artificial intelligence and machine learning and how this technology is different from traditional statistics. And finally, I will provide a very short definition of what petroleum data analytics is. Let's talk about how to code, learning how to code. To be a true petroleum data analytics engineer, you as a domain expert of this technology, you must become able to be a expert practitioner in AI and machine learning. In other words, in order to become a correct and real engineer in the future in 21st century, all domain experts in engineering have to become equally knowledgeable of artificial intelligence and machine learning, because this is a technology that's going to control uh, everything within the next few decades. Maybe the only way, if not the best way, of becoming an expert in artificial intelligence and machine learning as a practitioner is to try to build not one, two, or three, but hundreds or even thousands of purely data-driven models. And you should do this for years. Do not expect to become an expert in this technology in days or months, or by practicing a few times. Just think about it. How long does it take for you to become an expert in reservoir engineering or in drilling engineering? So this is the same thing. It's science, it's technologies. It's not something that you just learn in a few days. So it is extremely important for you to practice and practice and practice building models using this technology in order for you to become, in the context of petroleum engineering, in order to become a petroleum data analytics expert. To be a true petroleum data analytics engineer, the question is, do you need to know how to code? Well, the real answer is no. Really, you don't. At this point in time, it's very good to learn how to code using Python, as we are teaching in this particular course, to be able to build machine learning algorithms in order to do what you have to do and solve problems for petroleum engineering related issues. However, it is very important to know that it is good to do that today because there are not softwares out there for you to use them without knowing how to do these codes. But soon, hopefully, within a few days, years, sorry, soon there will be free machine learning and software applications for many petroleum engineering related problems that you will be exposed to. And when those applications are available and allow you to do whatever you want to do in a lot of detail in order to build data-driven models, then you really do not need to learn how to code as a petroleum data analytics engineer expert. Uh, However, if you choose to become a research person and try new modeling processes, or if you end up working for a company that their job is to build software for the industry, then yes, you must understand and learn how to code. The issue is that today, since free softwares are not available a lot for people to use them to build models, therefore it is a good idea to be able to learn how to code using Python in this particular course, and I'll explain why. But again, in a few years from now, hopefully, that will not be an absolute necessity, but it's going to be very helpful to all of you who are taking this course today. This course is Petroleum Data Analytics 620, and it's known as Python for Petroleum Data Analytics. It is part of a PDA certificate and master's degree that you will get exposed to computer coding and machine learning algorithm. There are many computer languages that can be used for this purpose, such as C, C#, C++, JavaScript, R, and of course Python, and we are concentrating in this course on Python. And let me explain it for a little bit. Python is an interpreted high-level general purpose programming language. It was created by Guido van Rossum in 1991. And today the version 3 of it is the one that everybody will be using. There are version 2, 2.7 and so forth, but everything is going to go start in version 3 forward. Python can be treated in a procedural way and object-oriented way or in functional way. That is why this is a very good technology in terms of coding to be used for this particular purpose. Almost 60% of all machine learning codes so far has been written with Python. That's one of the main reasons that we have used this particular language as part of Petroleum Data Analytics course. There is many open source libraries for machine learning algorithms, which Python includes the largest number of open source libraries for machine learning algorithms. Here's an example of different algorithms that are included in the libraries that are generated by in the context of Python, such as NumPy, SciPy, scikit-learn, TensorFlow, done by Google, but again in Python it can be used very correctly and very easily. Theno, PyChart, Pandas, and Matplotlib. With that introduction, let's take a few minutes and talk about paradigm shift. Developing new technologies require new ways of looking at the problem, new ways of thinking. This modification and this change in the way you think and look at the problem, it's called a paradigm shift. Because when the only tool you have is a hammer, then every problem you ever encounter tends to resemble a nail. However, in paradigm shift, things change completely. Attempting to solve problems in new ways, in a completely new ways, require a new set of tools, a new set of sciences, and new set of technologies. It may sound pretty radical in the first glance, but it's really not very radical. This is an attempt to learn how we solve problems as human beings, as Homo sapiens, and then try to mimic this approach to problem solving. In other words, finding out how as human beings we solve the problems. It would be great then if we could mimic that process and try to solve the problem using the way our brain solves the problem. That is the paradigm shift compared to how we solve problem as engineers up to today. How does this shift in paradigm constitute itself when it comes to oil and gas industry? Well, during the past decades, we have focused 3 decades actually took us at West Virginia University to focus our efforts to address this particular issue. Since beginning of 1990s at West Virginia University, we started doing research in artificial intelligence and machine learning. And of course, at the time, in the beginning of 1990s or late 1980s, this technology, although what we call it artificial intelligence and machine learning today, it was not called artificial intelligence. There is a pure history behind it that I'll be more than happy to discuss it in another course that you will be taking in this context or in this certificate and master's. But at the time, it was called soft computing. It was called virtual intelligence. There was so many intelligent systems. There were so many different things that they were saying in order to avoid calling it artificial intelligence. And again, as I mentioned, it has to do with the history of this technology. We'll talk about that in another course. But AI and machine learning is the main enabling technology that today, or actually a decade ago, started being called the fourth paradigm. Now the question is, what is fourth paradigm? Well, paradigm is the way you approach and explain issues and problems when it comes to science and technology. The very first paradigm was when science and technology was purely empirical. Thousands of years ago, people would describe the natural phenomenon just by looking at it from a purely empirical point of view. The very first paradigm shift, which was the second paradigm, took place a few hundred years ago. And that was when theory was generated when it comes to science and technology. Models were built using math, and this idea was to generalize the theoretical physical phenomenon that takes place. Newton's law of motion, Kepler's law, and Maxwell's equation, these are what had made the big paradigm shift during the Age of Enlightenment and during the Renaissance in Europe. That was the second paradigm of science. It went on until a few decades ago, almost in 50s and 60s, when there was science and technology came up with a completely new paradigm shift again. And this third paradigm of science was the computational paradigm. That's when the computer simulation came to be. When computers were generated and numerical simulation in our industry became very, very important, and then other numerical simulation from many, many other science and technology areas became quite common. And it had to do with the fact that some of the models that were generated in the second paradigm of science during the theoretical part hundreds of years ago, these mathematical equations were very, very complex, that they were not, we were not able to solve them analytically. And that's when the numerical simulation or the numerical solution to these very highly complex mathematical equation became what scientists came up with, and it became a real solution when we had computers that could help us do the numerical simulation in a very fast fashion compared to when it was done by hand. And finally, now we are at the fourth paradigm of science, and it's called the data-driven one, and that has happened today. And by today, in the context of history, I mean it took place literally in mid-80s, 1980s. And it unifies theory and experiment and simulation. And AI and machine learning is literally what created or gave rise to the fourth paradigm of science. As Jim Gray, which is a very famous computer scientist, American computer scientist who passed away in 2007, mentioned that techniques and technologies for data-intensive science are so different that it's worth distinguishing this particular technology, data-intensive science, from computational science as a new fourth paradigm of scientific exploration. This whole idea behind paradigm shift of science and fourth paradigm was something that Jim came up with. Now let's come up with some definitions. Artificial intelligence is defined as the technology that mimics human brain in order to perform analysis, to do modeling, and do decision making. Machine learning is defined as the use of open computer algorithm to learn from data instead of explicit programming. So during computational science, prior to AI and machine learning, the third paradigm of science, and we still do a lot of that, numerical reservoir simulation, very good example of it, we explicitly program and we tell the computer exactly what to do in incredible amount of detail, step by step, how to solve the problem and how to build the model. In machine learning, you don't do that. You do not tell all the details step by step to the computer algorithm of what to do. Rather, machine learning is an open computer algorithm that can be used for multiple type of problem solving. The problem that you're trying to solve includes a large number of data, and you use that data in order to teach the computer, the open computer algorithm, how to form itself in order to build a model. That's why it's called machine learning, because you have to teach it using the data to do that. And of course, deep learning is learning from data by pattern recognition using artificial neural network, which will be the basis of this particular course. So as I said, artificial intelligence mimics life to solve complex and dynamic problems. One of the algorithms that we use in AI and machine learning is artificial neural network. And it mimics the life and nature through human brain's information processing. Because human brain processes information in a very different fashion that computers do. Human brain processes information in a parallel distributed fashion when it's compared to computers, which instead of parallel, they use sequential processing of information. And instead of distributed, it does it pointwise, one piece at a time. Artificial neural networks is mimicking neurons in the human brain for the learning process. Learning through pattern recognition by using data to train the computer algorithm. Another algorithm that we're going to use, or another science we're going to use, is fuzzy set theory in the context of artificial intelligence and machine learning. And fuzzy set theory mimics human brain's logic. And mimicking this multi-valued logic used by the human brain, because unlike computers that use two-valued logic, the Aristotelian logic of a binary 0, 1, yes, no, black, white, off, on, our brain doesn't processes information and makes decision based on two-valued logic. Our brain deals with it in a multi-valued logic, a fuzzy logic. And this algorithm is trying to avoid the limitation of two-valued logic and expand it in order to be able to build models and to make decisions in a reasonable fashion based on the data that is not very exact, because our brain does not use exact data. The real data is never exact. And finally, the other one is genetic algorithm, which is an optimization technique, and it uses natural selection to do that. It mimics Darwinian evolution theory for optimization purposes, and it's finding solution and optimizing complex problems using a natural selection, which is an idea that Darwin came up with about 150 years ago. Thank you very much. We will continue as we move forward with the next presentation. Thank you.